So we had looked at the possibilities for life within our own solar system. Now we're looking at other solar systems, and that depends on basically the number of stars in the universe, the types of stars and the star systems, the rate of planet formation, the distribution of planets in each system, and the lifetime of each whole system. Right, it's moving forward. That's good. So we all know, I'm sure, stars are congregated in galaxies like our Milky Way galaxy. Fairly typical. There are others much smaller and others much bigger. So it's just about average. And that's a picture of our Milky Way galaxy that I took when I zoomed off in my spaceship a few 100,000 light years above it. Of course, it's not. It's just one that would be very like our Milky Way if we could do that. It's a photograph of another spiral galaxy, and we would be about 2/3 of the way out from the center towards the edge if that really was our galaxy. So we think at the moment the figure keeps going up, but between 200,000 million and 250,000 million stars in a galaxy like ours, each one on average like the sun, about 100,000 light years in diameter. So 50,000 light years in radius. And as I said, we're about 30,000 light years, or 2/3 of the way out from the edge, from the center towards the edge in a spiral arm. Just a perfectly ordinary sun. If that was a photograph of our galaxy, you would not see our sun. It's not bright enough to show up, but it's fine as far as we're concerned. So to give you some idea, I just love this picture, partly because of all the variety of colors, and they're genuine colors. They show that stars can be red, like Betelgeuse, which mentioned earlier, or very bright and hot and white, like, say, Spica or something like that, or Rigel. And that's just a tiny little part of our own Milky Way galaxy. It gives you some idea of just how many stars there are. Looking out, and this is a very busy slide, an awful lot of information in it, but it's a genuine 3D representation of the structure of our local universe. You may recognize some names there, like some of the galaxy clusters. Now, it's not to scale in terms of the fact that our Milky Way, which we see edge on there in the center, is nowhere near. It would be invisible basically in terms of the rest of the picture, but that's to give you the orientation of the flat plane of our Milky Way. And those are all galaxy clusters and superclusters of galaxies and other structures that we know of in our own Milky Way. So this idea that the whole universe is full of other galaxies isn't fanciful, that those have actually been mapped and plotted by a variety of techniques, visual astronomy and radio astronomy and so on. So we know that there's a huge number of other galaxies and galaxy systems quite close to us in the rest of the universe. And if we try and work out how many we are, I forget when I last updated this slide, but it doesn't really matter because the figures are so large. What I have there, the last best estimate, about 200,000 million other galaxies, each one with, on average, 100,000 million stars. And I'm not going to read out the figure down at the bottom. That's, on average, that number of stars. When I say on average, like our sun, that really is an average. An awful lot of them are much smaller and fainter and dimmer and redder, but others are a lot hotter and brighter and so on. But on average, there's a huge number of stars, pretty like our sun. And this takes you back to, or takes us on to another image that a lot of you will be familiar with. The Hubble Space Telescope was used to take an extremely long exposure to try and look out to the very edge of the universe as far as you could possibly see. And because not only our own galaxy is full of stars, but there are a whole lot of other galaxies all around us, what they did was to choose an area of the sky where they could see practically nothing. And then they exposed for basically 1 million seconds, not all in one go, but a cumulative exposure of about 1 million seconds to see what the Hubble Space Telescope could see out there. And it saw that basically the whole universe is full of stars. Our galaxy, sorry, that's just a tiny, tiny little part of our universe. And you'll see one star there, which is the one with the artificial little cross on it, which is caused by an artificial effect of the optics. But everything you can see there down to the faintest smudge, and you can't see all of them, And even I can't see all of them on a computer screen. But if you had that on a really high resolution screen and looked at it with a magnifying glass, you would see little galaxies there that are so faint and small and far away that they're not visible just on the ordinary screen. And if we zoom in to the top left-hand corner, sorry, I was forgetting about this slide, close up of the top left corner, again, you see that star there, that's a star. Everything else there is a galaxy. Some of them are moderately close to us, where you can see the structure like that one. And there's a barred spiral, which is like our Milky Way, and others are just tiny, tiny little smudges. The universe is literally full of galaxies. How many of the stars have planets? Because as we said earlier, basically, we're not going to find life on a star itself. It's going to be a planet. And a reasonably up-to-date estimate, over 5,000 candidate exoplanets. So those are ones that look as if they're exoplanets, but they haven't been observed long enough yet to be confirmed. But there are over 4,200 confirmed ones in 3,070 planetary systems and 669 multiple systems. In other words, there's more than one planet found in a particular system. Now, that's not a very big number in terms of the number of planets, but remember, it's incredibly difficult to do. Stars are huge and very luminous. Planets are small. They have no light of their own. They shine only by reflecting the starlight of the star they're orbiting. So it's like trying to detect a tiny firefly sitting on the rim of a powerful searchlight, which is shining straight at you from about a mile away. And we have to use various other techniques, and we only can only detect a tiny, tiny percentage of the total number of planets that are out there, because it is so difficult to do. So if we find that many already, there must be many, many more. And in fact, the latest thinking is basically almost all stars do have planetary systems going around them. Not all necessarily suitable for life, but they almost all have planets, or have had planets. Now, most of what we know now about other planets came from the Kepler Space Telescope. And if you look at that slide there, you'll see that down at the bottom where the figures are in blue, I can't see the logo on the right of this because part of my screen is blocked. But basically, the discoveries by blue were made by other methods, mainly gravitational perturbations. But the Kepler results were made in green, and that was using the transit method. I'm not going to go into detail about that. But once Kepler came online and started producing results, the number of discovered planets went way, way up. And although Kepler is no longer active in the way it was supposed to be, there's still results coming in. So what could an extrasolar planet look like? And obviously we haven't got a detailed picture yet, but that could well be what it's like, a giant planet like Jupiter. It's got its own little red spot there, and other moons. And it's not surprising that the biggest ones are the easiest to find, whether we're using the gravitational perturbation method or the transit method. So we find a lot more big planets like Jupiter than we do small planets like Earth. So what about our own planets and life? As I say, we'll just have a refresher on this. 8 planets in our solar system, maybe 2, Earth and Mars, plus possibly 2 moons, have conditions suitable for life. Many other stars have planets, about 50%, that's being conservative, but they're not all suitable for life, certainly not advanced life. If they're binary or triple stars, that means the orbits of any planets going around them will be probably chaotic and unstable, with considerable major changes in climate depending on where the position of one star is relative, or one planet is relative to its star. Some are just naturally variable, and some of them vary by a factor of tens or hundreds of thousands of times in brightness. So any life there would probably find it very difficult to survive. A lot of stars are too young. There has been no time for evolution to occur on any planets going around them. So if we're conservative and say that only about 5% of the planets that we discover or are out there have orbits suitable for life, in other words, fairly stable and not too hot, not too cold, and maybe only 1% of those have a planet in the habitable zone. You can have a habitable zone without any planets in it. And if we say that only 0.1% of those have conditions suitable for the evolution of advanced intelligent life, which means very long-term stability in both the star and the orbit of the planets going around it. And we again are conservative and imagine that only in 0.1% of those did intelligent life evolve, and only a tenth of those, 0.001%, is that intelligent life still active and communicating. Even so, that gives us 2 million stars in our own galaxy alone with conditions suitable for life. And that leads us to the famous Fermi paradox. Where are they? If the universe is teeming with life, where are they? And apparently he literally just said that to some of his compatriots, or his colleagues, I should say, over coffee in the university canteen or wherever. If the universe is teeming with life, where are they? And they're not here. Or, as some people think they are. So what are the options? Have they been here and gone away? Are some of the god myths that exist all around the world relics of past visits? Are they still here, incognito among us? And we can all think of one or two odd characters that might possibly be alien. Are we, in fact, they? In other words, were we brought here? Were we planted here? Are we colonists brought here in the distant past by some other civilization? Probably not, but who knows? Are they in the cosmic neighborhood watching and waiting? Now, we've been searching via radio for over 50 years, probably over 60 years now, for signals from another intelligent civilization with nothing detected yet. So what's the explanation? Well, most serious scientists say no to the questions 1 to 5 above. That's none of those reasons. So what other explanations are there? Well, first of all, they might be there, but they mightn't visit us. Maybe it's just too far away. The nearest other civilization might be a communicating advanced civilization, might be 100 light years away, and that's the figure in miles. So even if they could travel at a very, very optimistic 90% of the speed of light and allow for acceleration and deceleration at the start of the trip, that's about 150 to 200 years for a one-way trip. Would we be worth it? That's a matter of opinion. Much more realistically, and forget about Star Trek and Star Wars and all the rest of it, about 40% light speed is a reasonable assumption for interstellar travel. That makes a one-way trip of about 300 years. And I doubt if little old Earth is really worth that, especially as there might be a whole lot of other more interesting planets in the universe, or even in the galaxy. Another reason why there might be any visitors, too dangerous or very huge cost, and it is a huge cost. I mean, Elon Musk is putting a huge amount of his own personal fortune into development, and Jeff Bezos as well. And NASA spent some considerable percentage of the national budget of the USA to get men on the moon. So as I was hinting there, it could be too risky. That's a photograph of the famous Challenger disaster. And another thing that's becoming an exceedingly great problem on Earth is that we have so many satellites now orbiting the Earth that it's not going to be too long before we have a number of collisions, and then you get what's called a runaway Kessler effect, where you get one collision creating hundreds or thousands of bits of debris, and they eventually collide with other satellites, and the same thing happens again. And you could end up with a planet so full of orbiting debris that it would be far too risky to send a crewed mission up into orbit around it, or to leave orbit. So that's a possibility.